microprocessor. Basically, so microprocessor is an example of computer system. A computer is a programmable machine that receives input, stores and manipulates data, information, and provides output in a useful format. The computer system consists of CPU, screen, monitor, speaker, microphone, mouse, keyboard, etc. All the systems are connected together and will give an accurate output. The block diagram of computer system consists of central processing unit, memory, and input-output unit. The memory consists of two types. One is RAM and another one is ROM. So all these memory I/O interfacing are connected through address bus and data bus to CPU. Then the first component is CPU, central processing unit. So the portion of computer system is a portion of computer system that carries out the instruction of a computer program. So what is our required output? We are going to feed the computer program through this central processing unit. The primary element carrying out the computer function, it is the unit that reads and executes the program instruction. The data in the instruction tells the processor what to do. So this is the basics about central processing unit. Then second one is memory. The physical devices used to store data or program. So memory is nothing but a physical device. So computer main memory comes into two principal varieties. One is random access memory, another one is read-only memory. Random access memory can be used to read and return to any time the CPU command, but the ROM is preloaded with the data and the software that never changes. So CPU can only read from it. So for the RAM random access memory, we can able to read and write at any time from the requirement of your CPU. But in the case of ROM, it is a preloaded data, so we have to read the instruction what we are already loaded in the program. So ROM is typically used to store the computer initial startup instructions. So in general, the content of RAM are erased when the power to the computer is turned off, but the ROM retains its data indefinitely. In a PC, the ROM contains a specialized program called BIOS that loading the computer's operating system from the hard disk drive into the RAM whenever the computer is turned on or reset. So whenever you're going to switch on your computer, you can see your BIOS. Then I/O unit. So input-output port refers to the communication between information processing system such as computer and the outside world, possibly a human or another information processing system, where we are going to interfacing and what we are going to interface. The inputs are the signal or data received by the system, and outputs are the signal or data sent from it. So device that provides input or output to the computer are called peripherals. This is very important, peripheral. So on the typical personal computer, peripherals includes input device like keyboard and mouse, and output devices such as display and printer. So input devices are supported to do the task, and output devices are used to know the status of the task. Then and also we have hard disk drive, floppy disk drive, and optical disk drive serve as both input and output devices. Then computer networking is another form of I/O port. So this is your data size. Nibble, we have used 4-bit to 4-bit. We can use. Then byte, we can use 8-bit. Word, we can use 16-bit, and the long word we can use 32-bit. So this is your range. For 4-bit, you can use 0 to 15. For 8-bit, you can use 0 to 255. Then for 16-bit, you can use 0 to 65535. And 32-bit, you can use up to so very long range. This is your normal data system. Internal structure and the basic operations of microprocessor. So microprocessor contains this all: ALU, arithmetic logic unit, register section, control and timing section, and all. So we have a variety of buses, address bus to know where your data is going to store. The memory location is identified from data bus, address bus, and the data. So which information we are going to transfer from one processor to another processor. So it indicates the data bus. So it is a bidirectional. In both the direction, you can get the information. And also control bus, the control and timing section. It is also one of the block in the microprocessor block diagram. Arithmetic and logical unit. The component that perform an arithmetic and logical operation, the most important component in the microprocessor, and typically the part of processor that is designed first. So ALU is nothing but arithmetic logical unit. It is going to perform arithmetic logical operation. It is the most important component of your microprocessor. Then internal structure of ALU. It is a 2-bit ALU. It is a 4-bit ALU. Just nothing but a combination of logic gates. Then control unit. So each and every places we require control section to confirm the output. They are limited. The circuit that controls the flow of information through the processor and coordinate the activities of other units within it. This is very important thing. So we have to know the information, and also the information should be in the coordinate then activities of other systems also. So in a way, it is the brain, as it controls what happens inside the processor, which in turn controls the rest of the PC. And the regular processor, the control unit perform the task of fetching, decoding, managing execution, and the storing result. This is the normal control unit work. Okay. Then register. So this is the another most important element in the microprocessor. The register section or array consists of completely a circuitry used to temporarily store data or program code until they are sent to ALU. So register, this is the most important thing in the microprocessor, which can store data temporarily. Okay. So the particular data stored in the register. So then only the data is sent to the arithmetic logical unit or the control section or to the memory. Okay. The number of registers are different for any particular CPU, and the more register a CPU have, it result in easier programming task. The registers are normally measured by number of bits they can hold. For example, 8-bit register or 32-bit register. Then another important element is accumulator. So accumulator is used to store your result. A register in which intermediate arithmetic and logical results are stored. An example for accumulator using summing a list of numbers. The accumulator is initially set to 0, then each number in turn is added to the value in the accumulator. Only when all numbers have been added, the result held in the accumulator returned to main memory or to another or non-accumulator or CPU register. We are going to accumulate each and every data information to the accumulator. So consequently, we are going to add each and every single digit number. So condition of code register CCR flag. It is an 8-bit register used to store the status of CPU, such as carry, 0, or overflow, or half carry. So how much your register is stored data at present? It is tells about your CCR. So this is the generalist register we are using in the microprocessor. One is we are using the flag register. First one is 0 flag, carry flag, extend flag, negative or sign flag, overflow flag, or interrupt. So these are the 6 variety of flags register we are using. Then we'll describe each and every one. So first one is zero flag. So zero flag is nothing but indicate the result of the mathematical or logical operation was zero. So your operation is, the result is zero. It is indicated by zero flag. Then carry, which it has carry, indicate the result of operation produce an answer greater than the number of available bits. So this is flag may be also set before the mathematical operation as an extra operand to certain instruction. Example, add with carry. So this is your carry instruction. Then extend flag. So mask the XIRQ request when set. It is set by the hardware and cleared by the software as well. It is set by unmaskable XIRQ. And then sign flag or negative flag. It indicates the result of mathematical operation is negative. In some processor, the N and S flags have different meanings. The S flag indicate whether a subtraction or addition has been taken place, whether N flags indicates whether the last operation result is positive or negative. So these are the sign indication is given in this flag. Whether the work is completely done, it is a positive sign or negative sign. The overflow flag, it is indicated that the name itself, data is overflowed. To indicate the result of an operation has overflowed according to CPU word representation, similar to the carry flag, but for signed operation. So this is a signed operation, but the carry flag is not a signed operation. Interrupt. The interrupts can be enabled or disabled by respective setting or clearing this flag. Modifying this flag may be restricted to program execution in supervisor mode. So these are the 6 flags available in the microprocessor. The next information is program counter. The program counter is normally a 16-bit register used to store the next address of the operation code to be fetched by the CPU. Okay. So accumulator is nothing but it is going to store the result. But in the case of program counter, it is a 16-bit register used to store the next address of the operation code to be fetched by the CPU. Okay, not much used in programming, but as an indicator to user only. The purpose of program counter in a microprocessor to store address of top of stacks TOS, to store address of next instruction to be executed, count the number of instructions. So these are the things in the program counter normally do in the process. Then stack pointer. So stack is configured as a data structure that grows downwards from high memory to lower memory. So this words is derived from data structure itself. At any given time, the stack pointer holds the 16-bit address of the next free location in the stack. The stack acts as like any other stack when there is subroutine call or an interrupt, that is pushing the return address on jump and receiving it after the operation is complete to come back to its original location. So data bus, it is a bidirectional bus. We can send the data from one place to another place, one memory to another memory. So data instruction code from memory or input to output are transferred into the microprocessor. The result of an operation or computation is sent out from the microprocessor to memory or input output. Okay. This is normally used for transfer the data or transmit the data from a processor to IO port. So depending on the particular microprocessor, the data bus can handle 8-bit or 16-bit data. Okay. So depends upon the situation, you can do this data transfer rate by 8-bit or 16-bit. Then address bus, this is a unidirectional bus, okay, over which the microprocessor send an address code to the memory or input output. So first we have to send the address code to memory or input output. After that only for the particular memory location, we are going to send the data. Okay. So the size of the address bus is specified by the number of bits it